Our last piece in 4.6 is how do we actually use square roots to solve quadratic equations. So at this point, our main focus for solving has been to factor and then set each factor equal to 0. But there are ones that you don't have to factor that you can instead use square roots. So we're going to go through those. I want to show you different versions. I also want to make sure we use some of the simplifying that we did in the earlier videos. So first thing is you want to make sure that you isolate what is squared. So that's kind of our start, is make sure the x squared or the entire quantity squared is by itself. So first step for this one is to subtract 1 on both sides. So you get 2x squared equals 16, and then divide by 2. So you get x squared equals 8. Once you do that and you have it down to just the squared on one side and a value on the other, you want to take the square root of both sides to get rid of the square. This involves a couple things with our answer. First thing is, every time you take a square root on both sides of an equation, you will get a positive and a negative answer. And that's where this says taking the positive and negative square roots. So I will have a plus and a minus in front of the answer. And it is so easy to forget that. There is actually a button on Delta Math that allows you to do a plus and a minus at the same time. Next thing is, if your number can be simplified, like the square root of 8 can be broken down, then you need to do that to get your final answer. 8 can be broken down into 4 times 2. The square root of 4 is 2, and then the square root of 2 is left. So those are your two answers, the positive 2 root 2 and a negative 2 root 2. You can write them down separately, or you can use the plus minus to write both of them down at the same time. Next one starts off the same. You want to isolate the x squared. So I'm going to subtract 3 on both sides. So I have a negative 5x squared equals negative 12. Then I'm going to divide both sides by negative 5. So you get x squared equals 12 fifths. This one's actually a little messier than some of the other ones we're going to do. Take the square root of both sides. That will give us a plus and minus. I also can break down the 12 because 12 can be broken down into 4 times 3. So I'm going to do that while I'm at it. So I get x equals plus or minus. The square root of 4 is 2 root 3 over root 5. And now I have to rationalize. So I have to do what I did in the last video. I have to multiply the top and bottom by the root 5 over itself. So I get 2 root 15. I can do 3 times 5 over 5. And my answers are plus and minus, because when I take the square root of both sides, I have to include a positive and a negative. That one's about as messy as you'll see because it combines a lot of different skills. If there's parentheses, so if you have a binomial being squared, your first step is to isolate that parentheses, isolate that binomial. What you are not allowed to do, which is incredibly tempting, is you cannot distribute whatever is in front of the parentheses into it, because currently that parentheses is being squared. So distributing is not legal. So first step to get rid of the 1/3, I'm going to multiply both sides by the reciprocal. I'm going to multiply both sides by 3. So I get x plus 5 squared equals 21. Once I have the square root, or the squared all by itself, so I have that entire side being squared, I'm going to take the square root of both sides. That's going to leave me with the x plus 5 because the square and the square root cancel, and I'm going to be left with a plus and minus the square root of 21. 21 is not a perfect square. 21 also does not break down because there are no perfect square factors, so I can't do anything with it. I do have to get x by itself, so I'm going to have to subtract 5. So my answers are plus or minus the square root of 21 minus 5. You can write them separately. You can do square root of 21 minus 5 and then a negative square root of 21 minus 5, or you can do it one time. What you cannot do is you're not allowed to subtract the 21 and the 5 because the 21 is under a radical and the 5 is not. Next one, we have to get rid of the 3. So we're going to divide both sides by 3 to get rid of it. So we have an x minus 2 squared equals 7. Now that we've isolated what's being squared, I'm going to take the square root on both sides. So I get x minus 2 equals plus or minus the square root of 7. 7 is not a perfect square. 7 also does not have any perfect square factors, so I can't do anything with it. To get x by itself, I'm going to add 2 on both sides. So I get plus or minus the square root of 7 plus 2 as my final answer. Go back to a couple that don't have parentheses to make sure you're good with these. So I want to isolate the x squared, so I'm going to add 10. So I get 3x squared equals 36. Divide by 3. to get rid of the 3 in front of x squared. So I get x squared equals 12. I'm ready to take the square root of both sides. So I get x equals plus or minus the square root of 12. And 12 does break down. It breaks down into 4 times 3. 12 isn't a perfect square, but it does have a perfect square factor. So my final answer is plus or minus 2 root 3. The 2 comes from taking the square root of 4. For this one, I'm going to add 26 to start getting x squared by itself. So I have 2x squared equals 36. Divide both sides by 2. So I have x squared equals 18. Take the square root of both sides to get x by itself. Don't forget the plus or minus. 18 is not a perfect square, but it can be broken down into 9 times 2. The square root of 9 is 3, and then the square root of 2 is left under the radical. And don't forget the plus or minus in the beginning. Here's our last two that we're going to do, going back to the parentheses one more time to make sure you're comfortable. I want to isolate what's being squared, so I'm going to multiply both sides by 2 to get the x plus 1 by itself being squared. Take the square root of both sides, and that will get rid of the squared. So you have x plus 1 equals plus or minus the square root of 10. 10 is not a perfect square. 10 also does not have any perfect square factors. So I'm going to subtract 1 from both sides. So my final answer is plus or minus the square root of 10 minus 1. And again, I cannot combine the 10 and the minus 1 because the 10 is under a radical and the 1 is not. Last one for the video, I want to isolate what's being squared, so I'm going to start by subtracting 3. That will give us 72 on that side when I subtract 3. Then I'm going to divide by 2. This one actually has a little different ending, so I want to show you this. So I get 36. Take the square root of both sides, and here's what's interesting about this one. When I take the square root of both sides, I don't have to worry about breaking it down because 36 already is a perfect square. So you're going to get plus or minus 6 because the square root of 36 is 6. So what that means, when I add 4 to the other side, I get 2 answers, but they are whole numbers. I get positive 6 plus 4, so one of my solutions is 10. My other solution is going to be what I get when I do negative 6 plus 4. Negative 6 plus 4 is negative 2. So I do have 2 integer solutions. And this is only going to happen when I have a perfect square that I'm taking the square root of. So my 2 solutions are x equals 10 and x equals negative 2. And that is how I solve using square roots when I'm working with quadratics.